And welcome to building your own STELLA-AQ. First, we're going to take a look at the parts we need. And we need a battery, a power switch, a microcontroller, a screen, the real-time clock, the weather sensor, a CO2 sensor, and the particulate sensor, all displayed here on the sheet. Okay, let's gather our parts, and now we're going to put it together. There's the microcontroller that you'll be using, or that we use. Okay, so we're going to start with the battery first, and we're going to plug in the battery on the correct end. It's got a little notch. It's pretty hard not to be able to put it in correctly, and we're going to attach the button to the battery. Okay, make sure it's snug, and then we're going to grab the microcontroller, put the microcontroller in eventually. Alright, there we go. And then we're going to use a quick connect wire. Now make sure the shiny side is down when you push it in, and make sure that you push it in snug. I like to brace the receptacle, the quick connect receptacle, otherwise I have broken off one or two before. Now we're going to put on the screen. The screen is fragile, so be quite gentle with it as well, and make sure that it is snug, and again, brace the quick connect receptacle and put it in nice and snug. Alright, next we're going to do the time clock, the real time clock. Make sure you put a battery in there, make sure the positive is to the positive side, and just push it right in. There we go. Okay, then we're going to get another quick connect wire, and we're going to snug it in. Remember, shiny side down. Okay, you don't want to see the exposed wires. They face down towards the PCB board. Okay, and snug it up. Okay, make sure these wires are snug. Okay, if you don't do that, you can get some readings that you'll be missing some sensor readings. Okay, and then we're going to go and plug in the weather sensor. All right. And here's the weather sensor going in there. The BME 280 for this particular one is the one that we're using. Again, we don't endorse any one particular product, but these seem to work pretty well. Okay, and once we have those snug and we're feeling confident, we'll go ahead and plug in our CO2 sensor. So we'll grab our CO2 sensor. Do not touch the top of the CO2 sensor if you can. The oils in your hand can mess around with the ceramic plate on the top of that sensor, so just be careful. Oh, see, drop something. So we try to be careful, as careful as we can. These are pretty sturdy sensors, but still. Okay, snug that up. Okay, and then we are going to plug in our particulate sensor. But before we do so, it's got a little point of failure there, a single point, and we want to make sure it's sturdy and doesn't come off and doesn't jostle around, especially if we're putting it on a paint stick. We want to make sure that it's nice and snug and not going to get damaged as best we can. So I take a little bit of electric tape and wrap up the particulate sensor. Okay. There we go. And we should see it in just a second. There you go. Beautiful. Alright, and then we take our last quick connect wire and plug it. So we have a nice daisy chain going on here. And then in just a second, we will turn it on and see all the sensors lights light up. And if we do that, it means we have some good connections, generally speaking, and then we'll have to program. So there we go. There are some LEDs that are flashing on all of these sensors. Looks good. Now, and the screen is on. So in this particular one, I have already started a little bit of the programming, but we'll show you all of the basics, in just a moment. All right. So this is what it might look like, your STELLA-AQ. If you use a paint stick, that's something that we sort of generally use. I use Velcro and all that because I go and do outreach, and so I break it down and put it back together. All right, now let's get to the programming. Okay, so let's program our STELLA-AQ. Okay, first you must use USB-C data cable. Do not just use the charging cable. It will not work to put your code on. So USB-C data cable so that you can get the code on. Now navigate to where your files are for the STELLA-AQ. You should see something that looks quite a bit like this. And when you're plugging in your microprocessor, make sure you hold down the boot. Okay, you hold it down and you should get RP1-RP2. And once you do, it should come up in a second. There you go. You go to your UF2 file and drag and drop your UF2 file in there. Okay, and it might take a second or two, and it will copy over. And when it's done copying over, you will get the CircuitPy drive. And it does take a moment. So once that's done, yes, trick up the UF2 file. Now you're going to go to your AQ code and libraries. So I'm checking out the inside of the code that's on the microprocessor. Okay, let's see. AQ code and libraries. Okay, so we have two different libraries. We have one for the 128 by 128 screen and one for the 128 by 64 screen. All right. In this particular example, I'm using the 128 by 128. Luckily, I already put the files on there. So instead of doing that, we're going to go and pop our set clock, which is our code.py from set clock, and we're going to set the real-time clock on this thing, and we set it to time in UTC. Okay, so there's actually two different ways of doing that. One is via the GUI down there. In the serial portion of your Mu viewer, you will see that you can set the time clock there, or you can set it up at the top. Again, we navigate to time.is/UTC to get the time in UTC. Now, when I do set this time, I am going to set it I'm going to save this file about 5 seconds later than what's on the time in UTC over there, because it does take about 5 seconds. So you'll see what I mean in just a moment. So I'm setting the hours, setting the time, just verifying, go back and forth between the time UTC and all that to make sure that everything is set correctly before I save this. And like I said, I set it ahead of time just a bit, make sure everything corresponds, month, day, time, and what day it is, and then I would hit save. Okay, and eventually the code at the bottom when the serial would propagate and show me what time it has set in there. Now make sure when you do this you type in true over at the top there, and then once you have it saved, you're gonna go back and call it false and then save it again. Okay, and basically that just locks in your time. Okay, but like I said, there's two different ways of doing that. You can also use the GUI. Okay, and then we're going to get our code.py there. It's our regular libraries. Okay, and it takes a second to copy over as well. And once that copy's over, it's best to have your Mu editor on and ready to go, and you can go back into your Mu editor and load up the code from your microprocessor. So let's see here. Let's hit load. Navigate to our microprocessor. I guess it would still finish saving. All right, now we should see our code here. Okay, this is the actual STELLA-AQ code. Okay, developed by Paul Mirel. All right, this whole instrument was developed by Paul Mirel and Dr. Nissa Rain. They worked together to develop this, and Paul built it, and it's going to run through its code. See, we got the time and the UTC. It's writing the batch file, and now it's taking data. And you're going to see the data just go back and forth. I did not put an SD card in here, so there's an error reading an SD card. And this is what it would look like once it's finished. And please note, official AQI is calculated from a 24-hour average of particulate densities and includes time averages of CO, O3, NO2, and SO2 concentrations, which are not measured by the STELLA-AQ. Thank you for joining us on how to build and program your STELLA-AQ.